Okay, let's get started again. So we're given a list of numbers. The following list contains the number of hours that a sample of 13 middle school students have spent watching television last week. So it says find the median. All right, so some of you have probably heard of that or even know how to do it already, but let me just tell you right now. So we've been talking about the mean or the average of a set of data. And that just means add them out, divide by how many you add together. Well, the median is another way of determining the center of a set of data. Sometimes the mean is the best way. Sometimes the median is the best way to get an idea of what the middle of your data is. Sometimes they're both very close, and so it's worth looking at both of them. For example, if you're buying a house and you say, okay, I'm interested in buying a house that's 1,500 square feet and, two-car garage and 3-bed, 2-bath, or whatever, so something standard. And so you talk to your realtor and you say, okay, what is the median price around here for something like that? And then they'll tell you, I don't know, it changes. Oh, here comes my dog. Hey Zoe, come on over. And they'll say something like, well, the median for something like that is 300,000. Okay. And so and then that gives you an idea. Oh, okay. So if I find one for 250, by time 250,000, all right, well, that might be a good deal. And of course, it's like, okay, well, do I have to redo the carpet and the flooring and everything else, or what? So anyway, so the median is another way of getting an idea of what the middle of your data set is. So to get the median, you put all of your numbers in order, smallest to biggest, or vice versa. Okay. And so we'd say, all right, smallest number is a 4. Next biggest is a 6. And what else we got? So we got a couple of 8s. And then we're out of the single digits. Oh, we got a 10. And then we've got a 12 and a 13. Let's see, 16, 17, 18. Another 18, a 19 and a 20. All right. So, excuse me. So it's just the middle number. All right. So you would say, all right, well, let's get rid of those two. Then we'll 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 get rid of those two. And that's the guy in the middle. So the answer is 13, which has nothing to do with the fact that there were 13 numbers in the set. That was just dumb luck. Okay. So the middle number, you can see why finding the middle number might be, well, it definitely could help you find the middle of your data set. Okay. And that is how it's done. Okay, on this one, this one's a little different, only because there is an even number of data points. So just like before, you put them in order from smallest to biggest. So 7, 7, and 8. Then we've got a couple of 10s. And then 11, 16, 16. All right. So then we're going to knock off those two and knock off those two and just work our way to the middle. But if I knock off the last pair, these two, then I don't have any numbers left. So when you have an even number of numbers, that's what happens. And what you do is you just take both of them and you find the mean of those two. And then that'll be your answer. Now, in this case, they were the same numbers. So yeah, it worked out, pretty nice. But yeah, so if there is no middlemost number because there is an even number of numbers, then you just find the mean of those two middle numbers, and that'll be your answer for the median. So those are the only two situations you'll encounter. All right, on this one, now we find the mode, okay? So like I said on the last video, the mean is a good way of finding the middle of a set of data, but not always the best. Okay, sometimes, like for example, if your data set is this data right here, but then you've got one really weird one of like 12. That's just really not at all close to the others. We call that an outlier. We'll explore that later. Pretty quick here. This outlier can really throw off the mean and change things, especially if it's really extreme, you know, if it's like 20 or something more. So so the mean can really be affected by outliers, but the median does not tend to be affected by outliers, and so there are times when median will be preferred over mean, and vice versa. Well, a third way of getting an idea of the middle of your data would be mode. Okay. Mode is just the number that occurs the most often. So if I do a quick frequency distribution here, I can say, all right, well, we got zeros, ones, twos, threes, and fours. We got 1 0, a couple of ones, you know, a couple of twos, 3 threes, and 1 4. Okay. So which one occurred the most? Well, that one right there. 3 occurred 3 times. So the mode is 3. Okay, 3 pets. Me, I'm in the 1 pet category right now. That goofy dog that just walked in. You might think, okay, well, yeah, I mean, that makes sense. Often the number that occurs the most often is going to be around the middle, but not necessarily. So when might you use that? Well, what if instead of counting numbers of pets, you were counting what, you know, people's favorite ice cream is: chocolate, vanilla, strawberry. And then you say, well, we had 12 people chose chocolate, and 9 people chose vanilla, and 8 people chose strawberry. Okay, well, you're not going to be able to find the mean or the median of these. You can't find the mean because chocolate, vanilla, strawberry aren't numbers you can add together and divide by how many you add. And you can't put them in order. Who's to say that chocolate comes first, besides me, or vanilla comes first, or strawberry? But you could say chocolate because it occurred the most often. The mode is chocolate. That's the center of our data. Okay. So when you don't have numerical data, when you don't have quantified data, then yeah, mode is often your best choice. All right, so here we go. The following list contains the average annual total returns in percentage points for 10 mutual funds. Okay, so a mutual fund, that's just where you, your money, usually through a financial manager of some sort, your money goes to an investment for you to save, presumably for retirement, but it could be for anything. And it gets split up between your $1,000, for example. If it's just $1,000, that gets split up between the whole bunch of investments that are all kind of bundled together. Okay. Anyway, that's we don't need to worry about that. Okay, the mutual fund funds appear in an online brokerage firm's all-star list. So I'm seeing find mean, median, and mode. So because of median, I'm thinking, okay, I'm going to want to put these in order at some point. And in fact, I see that right there. So let's just put them in order right now. So the smallest one is -10, and then -2. I don't know, what else we got in? It's like 5 and 8. And what's next? 14. 18, 19. I find it's easier if you cross them off. Okay, 32, 33, and 30, oh, no, 40. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just like we're supposed to. Okay, cool. So what is the mean of this data set? Okay, well, you know what I'm going to do? You might not like this because it might feel like cheating, but I can live with that. I'm going to use my calculator to do this to help me out. I'm sure you would too. Here's how I'm going to do it. I'm going to go stat enter. I'm going to go up and clear out these lists. And then I'm going to enter the data. Now, if I enter in the calculator, I don't have to put it in order. But it was good for me to do it, because I'm the teacher, and that way I'm pointing it out to you. Okay, so I've got the whole data list there. Everything's hunky-dory. Then I'm going to go stat, right, enter, and then calculate. And oh, look at that. The mean is 15.7. Cool. I think that's what they were asking for. What is the mean of this data set? If your answer is not an integer, round your answer to 1 decimal place. All right, 15.7. That's our guy. Okay. What is the median of the data set? Well, that'll be the middle number. So if we go, oh, I got to turn that on. If we do get rid of those two and those two, I know I'm going to be picking the 2 middle ones because there's an even number of numbers. And those two and those two, and then so these two here. So the median. Oh, and sometimes you'll see an X with a tilde over it. That means median, just as X bar means mean. So we're going to take the mean of those last two to get the median. I get 16. However, comma, on the calculator, if I scroll down, hey, there's median right there. Boom, ba-dum, ba-dum. Now this is not going to do mode for me, but that's okay. I think I can handle that. All right, so we got 16 there. Okay, so part C. How many modes does the data set have, and what are their modes? Well, the 8 occurs twice, I think, or is that? No, that's a 5. Okay, hang on, let me get rid of some of this stuff so I can read it a little easier. Okay, yeah, 5 and 8. Okay, so so none of the numbers occur more than any other number. So we're going to say 0 modes. Okay, nothing occurs more than anything else. Now, if we had maybe another 8, we would say, oh, we got 1 mode, and it's 8. Okay. Or if we had that 8 and then we also had maybe a -2, we'd say, oh, now we've got 8 and -2 both occurring the most. I've got 2 modes, 8 and -2. And then that could happen. All right. But if no number stands out more than any other number, if every number occurs the same amount, they all occur once, they all occur twice, whatever, you're going to say no mode because it's not telling you anything. Nothing's standing out. Okay, now on this one, we're going to talk about something I was alluding to before when I said, yeah, what about the outliers and blah, blah, blah. Okay, so the weekly salaries for 10 employees of a small business are given below. Notice they're already listed in order from least to greatest. Oh, that definitely helps. Okay. Suppose that 1017, the 1017 salary changes to 1247. Answer the following. What happens to the mean? Okay. Well, let's find out. All right. So I am just going to let the calculator do the heavy lifting. I'm going to go stat enter, arrow up, and hit clear enter. And then I'm going to type in all the data. Now I want to compare the old set of data with the new set of data. So first I have to type in the original data. All right, so let's see, make sure I do this correctly. 8, 18. Oh, poop. Well, I did it incorrectly. Sorry about my language. Let's see, and then 8, 19, 847. I'm getting there. Don't worry. I'm slow, but I do poor work. That's how I make up for it. I've got a really loud fan on. My AC went out last night, and so I got this box fan on, and I did a test recording, and it didn't pick it up on my directional microphone. So I should be okay. All right, so now I'm going to go stat, right, enter. Okay, so for the original data set, the mean is 829. Okay. Okay, so the mean is 829 bucks. And let's see, what would be the median? I'm gonna scroll down, and the median is 833. Got it. All right, so record that. Notice they're only off by $4. Okay, so often, certainly not always, but often the mean and the median are going to be fairly close. Okay. All right, how about the median? That's our symbol for median. I don't feel like writing it all out. Okay, so it says now the 1017 changes to 1247. Okay, so I'm going to go back to stat, enter, and change this to 1247, which is not a huge change, but I mean, it's definitely going to make a difference. I mean, you can change anything. Okay. All right, so before we do the calculation, let's take a look right here. Okay. I changed that to 1247, which means I still have 10 numbers. I'm still playing around with 10 employees here. So these are still the middle two numbers right there. So it's still going to be 833 for the median. Okay, my pen is doing something janky. Okay. But what about the mean? Well, remember the mean, you add them all up, divide by how many you add together. And now you're going to add on a number that's even bigger, and therefore the mean will change. All right. So if I go stat, right, enter, and then down, the mean has changed to 852. Okay. So the mean went up $23. Okay, like I said, it wasn't going to be a huge effect on the mean. If we had, done quite a bit more and said, yeah, this is $2,000, then it would really adjust. And of course, you could go and check that out real fast on your own. So now we can answer these questions way easier. Okay, so what happens to the mean? Well, the mean increases by $23. What happens to the median? It stays the same. Okay, and so those are things to be aware of. So yeah. Now, if we had tacked on an 11th number, like 1300 or whatever, now the mean, or the median is going to change. There's 11 numbers. That's an odd number. And therefore the middle number, 847, would have been the median. Okay. And so if that had been the case, then the median would have changed, but well, that wasn't the case. As promised, it is now time to talk about outliers. Okay. Outliers are numbers in a data set that are very extraordinary. Or at least they're sufficiently unusual that, they're just kind of off the beaten path from all the others. Okay, so a bakery sells 11 types of sandwiches. Here are their calorie counts. Looks like they're in order from smallest to largest, so that's cool. Okay, so 593, and then we only go up by one, we only go up by two, we only go up by one, by one calorie, by zero, by one, by three, by three. There's nothing extraordinary here. It's not like, hey, there's a 300 calorie sandwich. Whoa, that's unusually low. Or, hey, there's a 700 calorie sandwich. Okay, I only need 3 of those for the day. I've got all my calories. So we would say none for that one. Okay, so let's try another. All right, so one more of these. So are there any outliers? Well, the 10 participants in the experiment had the following reaction times in milliseconds. So, okay, so we've got all those. We could find the mean, the median, the mode, but that's not what we're being asked to do. Hey, Zoe. And there are some, in a statistics class, we would show you some ways to quantify for sure whether or not you've got an outlier. Okay, there's different ways to do that. One way would be to say, well, let's just, no, let's not get into that. Okay, so take a look at all these. Well, notice these guys right here, they're all, pretty close to each other. And then you've got that guy unusually high and that guy unusually low. Okay, they're definitely not part of the main group. And so in this case, there are 2 outliers, one really low, one really high. Like we saw a few moments ago, if you have an outlier, that can really throw off your mean. However, if you have one really high and one really low, well, when you're calculating mean, they'll kind of average each other out, even each other out. So that if you have a high and a low, they might not affect the mean very much. Maybe. But again, it depends. Like if you've got a 234 for a low, but your high is like 5,000, can you imagine a 5,000 calorie sandwich? I mean, without it being like, 8 feet long, that would just be nuts. Anyway, I mean, yeah, you'd certainly have an outlier on the top, an outlier on the bottom, but they're not going to average each other out because this 234 is way closer to the main group than the 5,000 is. So anyway, I'm just throwing extra information out there just so that you're aware of it and thinking about it. Okay, last topic for this video. Choose the best measure to describe the data. Oh, okay. So is it mean, median, or mode? My brother teaches this stuff at another college, and the way he describes it is, all right, if mean, median, and mode all got into a fight, who would win? Well, I guess it would depend on the set of data. But all right, whatever. It's kind of weird. Okay, so the following number of people attended the last 10 screenings of a movie. And here's how many each time. Okay, which measure should be used to summarize the data? Okay. Okay, now the way that Alex approaches this, it's a good way, but it's not a completely comprehensive way of looking at it. So the first one, mean or median would be good, but here's how we're going to do it in the homework and on the test. We're going to say, well, because there are no outliers, we're going to go median, or we're going to go mean. Okay. Whereas on part C, it's all numerical data, so it's going to be mean or median. But there is an outlier of 88. Okay. And like we've seen, that outlier can throw the mean off, so we're just going to do median. Now and then part B, well, the data is not numerical, so you've only got one choice, and that's mode. Uh-oh, my wife just started mowing the lawn. I got to get out there. Okay. All right. And that is it for today.